our learning goal says I can write a linear equation in slope-intercept forms. We already worked with that yesterday. I can graph a linear equation using slope-intercept form. We've been graphing two other ways so far. Make a table, pick some x values, substitute those into the equation, get your y values, you have ordered pairs to graph. The other way we learned is when the equation is specially given to you in standard form, it's fairly easy to find the x-intercept and the y-intercept to help you graph. And then you just use those 2 points. Today we're going to use slope-intercept form to help us graph. The book had you just do 2 points, I believe. Here's where I differ. You have to do at least 3 points if the coordinate plane that I provide for you, or is provided for you on a worksheet or wherever, if it will fit 3 points, you have to have a minimum of 3 points to make your line. Okay? So, I say a linear equation solved for y, as in yesterday's exploration. Well, no, really, I don't think we did an exploration. Maybe we could say as in yesterday's notes, is considered to be in slope-intercept form. So in other words, we know that when we have y alone equal to the x term on the other side and a constant maybe being added to it or subtracted from it, we have slope-intercept form. What's our m representing again? Slope. So whatever x is being multiplied by, what you do to x to help you get y, whatever x is being multiplied by is considered to be the slope, and the b is the what? The y-intercept. And the y-intercept means what again? Just a simple explanation. What does y-intercept mean? Where it crosses the y-axis. Where is this line going to cross the y-axis? And x and y can be ordered pair solutions. How many ordered pair solutions do you think any linear equation has? How many ordered pair solutions? Well, let's see. Let's go with this equation. Y equals 3x minus 1. How many ordered pair solutions do you think y equals 3x minus 1 has? First of all, what would be the slope of that equation? Y equals 3x minus 1. 3. What would be the y-intercept?
0.
Y equals 3x minus 1. 0, negative 1, or it would be crossing the y-axis at negative 1. We would just go down to negative 1 and make a point. Okay, so does that mean that point and another point that you make using the slope, are those the only 2 ordered pair solutions that line would have? How many would it have? An even number of solutions, an odd number of solutions, a cap to the number of solutions, an infinite number of solutions? What do you think? So we have this line, it's a line on a graph. Every point on that line has an x and a y value. Every ordered pair on that line. So how many ordered pairs can there be on a line? Yeah, there's an infinite number of solutions. So we can, but does that mean any x and y value that you put together will be a solution to that equation? No, there's a whole bunch of other points on that coordinate plane that could be plotted that would not fall on that line, so then they're not considered solutions. So the x and the y always combine to become an ordered pair from that line. So if you know the slope and the y-intercept, you can easily graph the line. This is the reason for slope-intercept form. It makes it so friendly for graphing it. So we're going to graph the line whose slope is 2 and y-intercept is negative 3. So we start by plotting the y-intercept. Go ahead and put that point on your graph. Where do you put the y-intercept of negative 3? Y-intercept means you are plotting the point on which axis? The y-axis. Trust me, oftentimes it's kind of easy to mess up and put it accidentally on the x-axis instead. So it goes on the y-axis at negative 3. Okay, this is where I'm a little bit different than the book. I want you to make 2 other points besides this y-intercept using the slope. Well, the slope for this one is 2. So I want us to talk about the 2 different ways you can always use slope. Okay, if you have a positive slope, that means you can have a positive rise and a positive run, or you can have a negative rise and a negative run, because a positive divided by a positive is a what? Positive. And a negative divided by a negative is a positive. So we have two different ways we can think of the slope, two different directions we can go from that y-intercept. We can go 2 up and 1 to the right, or we can go 2 down and 1 to the left. So I want you to plot 2 more points from that y-intercept. Using the y-intercept as your starting point, I want you to use the slope in the 2 different ways of rise over run. So we're going to have a minimum of 3 points. You can make more if you want. Just keep using that slope of going up 2, right 1, or down 2 and left 1. You can just continue that pattern and make as many points as you want, but you have to have a minimum of 3. Draw your line going all the way through the coordinate plane. That's what you have a ruler for now to use as a straight edge. So draw a line going all the way through the coordinate plane, not just through those 3 points and little arrows at the ends of them. And then ask yourself, does the behavior of this line match what I should expect? It had what kind of a slope? A positive. So a positive slope means the behavior should be what? Going up from left to right. It should be rising from left to right. So do we have a line that's rising from left to right? Yeah, we do. Okay. What's the equation of our line? What's the equation of this line? Go ahead and write it on your papers. What is the equation of this line? Cleaned up, how you would see it in an answer bank. What does it look like? So Avery, what's the equation of this line?
Y equals 2x minus 3.
Y equals 2x what?
Minus 3.
Minus 3. Okay. You guys agree? Okay. Now, we shouldn't just be happy to have an equation though. If we were given the slope and we were given the y-intercept, if we graphed it correctly, all those points that we graphed and any other point on that line for that matter should check out in that equation. So let's go and check out all 3 of our ordered pairs that we can pick from that we used for graphing here. So let's take that bottom one first. What's the ordered pair name for this one right here? What's its ordered pair name? Negative what? Negative what? Negative 1, negative 5. So we'll take our y equals 2x minus 3. What will we sub in for the y from that point? What are we going to put in for y? What's the y value of that point? Yeah, negative 5. So we'll put negative 5 in for y. We're just checking it out. We're not doing any solving here. We're just checking to see, is that ordered pair really a member of this equation? Because if we graphed it correctly and we wrote the equation correctly, this should check out. It should make the equation true. What do we put in for x? The negative 1 from our ordered pair. And then subtract 3. Well, negative 5 can't be simplified any. 2 times negative 1 is negative 2. And then we got that subtract 3 coming along. Negative 5 is just going to come down. It doesn't have anything that can be done with it. What's negative 2 take away 3 more? Negative 5. Is it because it really is or because we want it to be? Because it really is. Negative 2, if it's 2 below 0 and the temperature drops another 3 degrees, it does end up at 5 below. Okay. What's another ordered pair we can check out? What's the next one going up? What's its name? What's this one's name? 0, negative 3. Let's substitute it in and make sure it checks out. gonna end up with -3 equals -3, which means it makes it true. It is true, so it is a solution. Okay, what's the last order pair we can check out? 1, -1. Okay. Okay, substitute it into the equation that we wrote and make sure it makes it true. So I'm not going to make you do this in your homework, but I do want you to be able to understand that, especially if you're taking an assessment, if you want to help yourself decide if you have a good equation or not, then the points from your line that you graphed should check out in your equation. They should make the equation true. If they do not, then you don't have the right equation. Anybody have any questions? What's the minimum number of points you have to graph? 3, unless the coordinate plane won't hold. If you can't, you can only, without having to draw more grid lines, when you're provided a coordinate plane already, if you would have to draw more grid lines to get that 3rd point, you can skip the 3rd point because it does really only take 2 points to graph a line. Okay, let's go to the back side. Graph the line for the equation y equals -1/4 x minus 4. So the starting point, I always like to identify that first because that's really the first place you're going to go on your graph. So what is our y-intercept? -4. If we change this to how it was before it was cleaned up, it would be -1/4 x plus a -4. Before it got cleaned up, that's what it looked like. So our y-intercept is -4. Our slope is what? -1/4. Okay, I want to talk about that. How are the 2 ways we can use that -1/4? First of all, to get a negative when you're dividing, what has to be true? To get a negative answer when you're dividing, what has to be true?
One has to be a negative and one has to be a positive.
Yeah, one of them has to be a negative and the other one has to be a positive. So when we're using it as slope, that's the way we're going to think of it. One of them has to be negative, and then that means the other one has to be positive. So if we allow the rise to get the negative sign, then the run has to be positive. So we're going to go to down 1 and to the right 4. Or we have the option of saying, you know what, I'm going to let the rise be the positive, and then that means the run will have to be negative. So I can go up 1 and left 4. So the first point on the graph is going to go at -4 on the y-axis. From that, we're going to make 2 more points, preferably going in 2 different directions. If sometimes you have to go in the same direction twice, that's okay. But I would like you to be, if the coordinate plane supports it, I would like you to be using both ways. So I can go down 1 and right 4, or I can go up 1 from the y-intercept and left 4. When I'm done and have drawn my line through the 3 points, through the graph, I don't just, move on to the next problem. I do what? You do what? You don't have to do check problems, that's not what I'm talking about. What should you do though? Don't just rush on. What should you ask yourself? Does it have negative behavior? Does it have the behavior that a negative slope would have? What's negative slope do? Falls from left to right. Our line is falling from left to right, so we can feel at least confident about that part. We can move on, but we should not move on if the behavior does not match what should have happened. And trust me, very easily that happens when you're using the slope to plot those other points. Okay, any questions on graphing when the equation's already given to you in slope-intercept form? Okay, then we're gonna graph the line for this equation, but notice it says using the y-intercept and slope. Not using the x and the y-intercept, but the y-intercept and the slope. So what does that mean we're gonna need to do with this equation? It's in standard form, so we're gonna rewrite it as, what's that other form called over here? Slope-intercept form. So we're gonna get this put into slope-intercept form. So first thing we're gonna do is, if you have trouble with those negatives, is change it to add the opposite. What's our first move to get the y eventually alone? Get this solved for y. What should we do first? Haley? What do you suggest? Caleb, what do you suggest? Subtract 3. There's not 3 in there. Subtract 3x, you mean? Yeah. That's what I thought. Okay. Subtract 3x from both sides. Now, here's why it's beneficial for most of us to change it to add the opposite. Oftentimes students look at this right here and say, well, there's subtraction going on, so the undoing of subtraction is addition. I need to add 3x to both sides. That's not 3x plus another 3x is not going to make those x's move. They're not going to get out of there. Okay, so now we have the negative 2y by itself. Negative 15, take away 3x. Well, I can see I'm going to have to do some dividing. There's a negative sign involved. So I'm thinking that changing this to add the opposite would be a good move. Plus, and the opposite of positive 3 is negative 3. Because what's our next move? Divide everything by negative 2. Every piece gets divided by negative 2. So negative 2y gets divided by negative 2. Not by negative 2y. I have some students still doing that. We're not dividing by y. We're dividing by the negative 2 to get that away from the y. Okay, well, the y is by itself now. Got that accomplished. We have y equals a negative 15 divided by a negative 2. Is that a integer answer? Integers, remember, are whole numbers and their opposites. Is 15 divided by 2 going to be an integer? No. And a negative divided by a negative is a positive. Now, is this going to be, well, let's just leave it like this for right now. When it doesn't divide out nicely, we can leave it as a fraction. And how about our negative 3x divided by negative 2? What would that become? Is that an integer? Would that divide out to be an integer? No. What's a negative divided by a negative? Positive. And since 3 divided by 2 is not an integer, we're going to leave it as a fraction. Now, the thing that's helpful is to decide, first of all, if those two trade places, which they can do very easily with that addition, what's our slope in that one? 3 over 2. We like fractions for slope because we need to rise and we need to run. So we like fractions and slope. We don't want to change those to a nice decimal name. No reason to change that to a 1.5 or 1.5 because we need a rise over a run. But that 15 halves, what's that?
7.5.
Yeah, that's 7.5. We need to rename that one so that we know where to go on the y-axis, right? Okay, so we're going to rename that as, we're going to leave that 3 halves as 3 halves. But we're not going to leave that 15 halves. We're going to change it to a 7.5 or a 7.5. And then we are going to say, okay, our y-intercept, we'll start with b, is 7.5. So I'm going to go on the y-axis to 7.5. And there's no reason to change the scale so that the grid lines go by halves. You can go to 7.5 on the y-axis. Where's it at? Halfway between 7 and 8, yeah. So put it halfway between 7 and 8. And then our slope is 3 over 2. Which means then that we have, what, two options with that 3 over 2? What are our two options for that? We can go, it's a positive slope, so how do you get a positive when you're dividing? How do you get a positive when you're dividing? This is not a tough question. Why are we such whisperers? Two negatives make a positive when you're dividing, and two positives make a positive when you're dividing. So we have the option of them both being positive like they are here, which means we would go up 3, right 2, or, what's our other option? Down 3 and left 2. Now, I'm thinking that this is one of those times on this graph where it is going to support 3 points, but can we use both ways of slope without drawing extra grid lines? Because we need to go up 3 from this, so we got to go to 8.5 to 9.5 to 10.5. Is there a grid line for 11? No. So instead of using the up and to the right one, we're going to use the down and to the left one twice. So we're going to go down 3 units and 2 to the left, and we're going to have a point. From that, we will go down another 3 and to the left 2. And we do not have any of our points that we're graphing are on an intersection of integer values. One of them is an integer, and that's only the x value. The y values are going to be those fractions. So we're going to, this time to get our 3 points, we used the second name for slope twice instead of both names for slope. We don't move on until we ask ourselves this question. If I rearrange the equation correctly, that's a talent in itself. You got to make sure you do that right. If I rearrange the equation correctly, I say that this should have a positive slope. Does my line have a positive slope? Is its behavior matching that? Yes, it is, isn't it? Okay. The other thing you could do is if you would like, you seem to keep messing up putting it into slope-intercept form. The other thing you could do is find the x and the y intercepts because it's in standard form and see if it really does actually cross the x and the y axis where your graph does. That would be kind of like a way to check it. Anyone have any questions? You will use a straight edge to draw these lines, not you sketching them. I will provide the graph handout, like I said. You will have a minimum of 3 points unless the graph will not support 3 points. In other words, if your rise or run are so large that you cannot get a third point on there, then you can divide with 2. Otherwise, I have the expectation of a minimum of 3 points. You get your heading started, I'll get you the graphs handout here in a bit.